Okay, you should be open to page 63 in your workbook, which talks about rational and irrational numbers. So we're going to be figuring out if numbers are rational or irrational. We're also going to be doing different things with these, like putting them in order from least to greatest, seeing which one's smaller or bigger, putting them on a number line, so a bunch of different things. So first of all, we need to know what's the difference between rational and irrational numbers. Rational numbers rational comes from the word ratio, which means fraction. So rational numbers are all numbers that can be written as a fraction. Examples of these are integers, so any number, whole number, positive or negative. Fractions, it's pretty obvious a fraction can be written as a fraction. Terminating decimals are numbers that they're decimals. When you're dividing, you eventually get a remainder of 0. It's like 2.5. Since that 5 has a definite end, it doesn't repeat, doesn't keep going, it's a terminating decimal. And repeating decimals, so like 0.3 repeating would be 1/3, so that's a fraction. Irrational numbers, ir means not, so irrational are numbers that cannot be written as fractions. The only time that's going to happen is if you have a decimal where the decimal goes on forever without repeating. That looks silly. Some good examples of irrational numbers are pi. Pi goes on forever and does not repeat. And also, anytime you take the square root of a number that's not a perfect square. So, for example, square root of 5. There is no number times itself, that's a whole number, that's going to give me 5. So if I were to put that into a calculator, it would give me a decimal that goes on forever and does not repeat. So square root of 5, square root of 6, square root of 7, any number that is not a perfect square when we take the square root. We're going to be talking about how to place numbers on a number line here in a little bit, so they just showed us a quick example of how to do that. Typically we're going to turn them into decimals and figure out where they go, so we'll see an example like that. The question at the bottom, they want you to compare 3/5 and 0.65. So they want you to use an inequality symbol, which means less than, greater than, less than or equal to, or greater than or equal to. So to do this, since one number is a fraction, one number is a decimal, my advice is turn your fraction into a decimal. It's a little quicker. So I'm going to do 3 divided by 5, so top number on the inside, bottom number on the outside. 5 doesn't go into 3, so put a 0. Put a decimal and another 0. 5 goes into 30 exactly 6 times, so I get 30 with a remainder of 0. Now, some people, they automatically jump to 0.6 being smaller just because it has less numbers. We don't necessarily want that. So if you want, you can put a 0 on the end so that it has the same amount of numbers. When we compare decimals, we look at each place individually. So 0 and 0, same number, don't care. 6 and 6, same number, don't care. 0 is smaller than 5, which means this number is smaller. So that's where they got the inequality symbol, less than. Okay, please turn to page 64. For our think about it, it says, how can you tell if a decimal is a rational or irrational number? Well, we talked about that in the definition. So it is rational if the decimal terminates, so if it has a remainder of 0, or if it is a repeating decimal. It is irrational if the decimal goes on forever but does not repeat. Okay, so the next example, they want us to put these 3 numbers on a number line, and they're going to walk us through how to do this a little bit. So my numbers are -5/8, pi, and square root of 16. So first we need to figure out what is the decimal equivalence of -5/8. So to do that, I'm going to divide, and I'm going to do this off to the side. So divide 5 divided by 8. 8 doesn't go into 5, put a 0 in a decimal. 8 goes into 56 times. 8 times 6 is 48. subtract to get 2. Bring down a 0 because I want to see, am I going to get a repeating decimal, terminating decimal, or a number that just keeps going. 8 goes into 22 times. We get 16, subtract to get 4. Bring down a 0. 8 goes into 55 times exactly. So I got my remainder of 0, so I can stop. Since this was negative 5/8, I'm going to throw a negative out in front, call it negative 0.625. Does this decimal terminate? So in other words, did it get a remainder of 0? Yes, it did. Does it repeat? No, my numbers did not repeat. Is it rational or irrational? So this would be rational since it was a terminating decimal. What two whole numbers is negative 5/8 between on the number line? Well, if it's negative 0.625, that's between 0 and negative 1. Which whole number is it closest to? Well, negatives are a little backwards, so this is actually closest to negative 1. Plot and label a point to show the approximate value of negative 5/8 on the number line above. So it's between 0 and negative 1, but close to negative 1, so about right here. And I'm going to label that negative 5/8. Is pi a rational or irrational number? Well, I told you it's irrational because it's a decimal that goes on forever and does not repeat. What is the approximate decimal value of pi? When we talk about pi, we typically use 3.14. What two numbers is that between? That's between 3 and 4. So I'm going to put a dot. Oh, well, there are some questions. This is going to be kind of hard. I'm going to have to go back and forth a little bit. My next question was, which whole number is it closer to? Well, 3.1. Well, that's closer to 3. Plot and label a point to show the approximate location of pi on the number line. So I'm going to go back up. So sorry that I have to go back and forth. So pi 3 and 4, closer to 3, so about right here. And I'm going to put the pi symbol. Okay, going back down. Is 16 a perfect square? Yes, it is. There is a whole number times itself that's going to give me 16. So the square root of 16 was 4. Is square root of 16 a rational or irrational number? Well, 4 is an integer. We can write that as a fraction because it's 4 over 1. So that would be rational. So it's not a decimal that goes on forever and without repeating. So rational. And then they want me to put that on the number line. So I'm going to go up, put it on the number line. So dot at 4. And that was called square root of 16. Okay. Next, how can you order these three numbers from least to greatest using the number line? Well, you'd think they want some fancy answer, but they don't. All you have to do is write them in order from left to right. So the reason for that is because our number line, the numbers on the left are smaller than the numbers on the right. So if you want least to greatest, just write the numbers from left to right. How can you order these three numbers from greatest to least? Well, it's the opposite. Write them in order from right to left. Okay, moving down. If a number is not a perfect square, its square root lies between whole numbers that are square roots of the nearest perfect squares. So what we're going to end up doing is we're going to be given a square root of a number that's not a perfect square. We want to estimate what it would be. So we're going to figure out the approximate value of square root of 73. So what I'm going to do is think of my list of perfect squares. 1 squared is 1, 2 squared 4, 3 squared 9, 4 squared 16, 5 squared 25, 6 squared 36, then we got 49, 64, and 81. Now I'm going to stop there because I just need to get up to 73. What is the nearest perfect square that is less than 73? So 73 would be somewhere between here. So the next number that's less than would be 64. What's the square root of 64? 8. What is the nearest perfect square that is greater than 73? So 73 would be here. The next number up would be 81. Square root of 81 was 9. So the square root of 73 is between 8 and 9. The perfect square is 73, is closer to 81 than it is 64. So 73, it says, is 73 much closer to one number than the other, or is it almost in the middle? This is almost in the middle. It's pretty close to being in the middle of 64 and 81. Okay, and this continues on to the next page just a little bit. What decimal can describe this distance? Well, halfway, or the middle, would be 0.5. What decimal can you use to describe the approximate value of square root of 73? Well, if it's between 8 and 9, and it's about halfway between, that'd be 8.5. Next, use what you know about rational and irrational numbers to answer these questions. Compare square root of 38 and 6 and 5/6. So the square root of 38, that's pretty close to square root of 36. So maybe about 6.2, because 38 is pretty close to 36. 6 and 5/6, that's pretty close to 7. When you do 5 divided by 6, you actually get 6.83 repeating. So compare 6 and 6, that's the same. 2 and 8, 8's bigger. So the square root of 38 is going to be smaller than 6 and 5/6. Number 2, which of these numbers are irrational? So square root of 6, there's no whole number times itself, that gives me 6, so that's irrational. Square root of 8, no whole number times itself, that gives me 8, so that works. So don't accidentally divide it by 2 and get 4. 4 times 4 is 16. Square root of 9, well, that's 3, so that was a whole number. Square root of 12, no number times itself is going to give me 12, so that's irrational. Okay, last page that we're doing together. Marcy performed a calculation. The result was 4.83 repeating. Which number best describes 4.83, rational or irrational? Well, since it has that repeating number, that tells me it's going to be rational. So explain how you know. It's a repeating decimal, which can be written as a fraction. Number 2, square root of 2. Oh, I'm going to actually move. No, it's fine. Okay. The number square root of 2 is red square root of 2. Part A, is square root of 2 a rational number or an irrational number? So I'm going to think, is there a whole number I can multiply by itself to get 2? The answer to that is no, so it's irrational. Because 1 times 1 is 1, 2 times 2 is 4. 2 is completely overlooked. Part B, explain how you know. It is not a perfect square. So you would get a decimal that goes on forever without repeating. Okay. We have one more question, part C, at the bottom of this page. Part C, on the number line below, draw a dot to show the approximate location of square root of 2. Well, square root of 2, that's between square root of 1 and square root of 4. Square root of 1 is 1, square root of 4 is 2. Square root of 2, that's closer to 1 than it is 4. It's actually about a fourth of a way. And 1/4 is 0.25. So I'm looking for 1.25. So I can finish this number line first. Between 1 and 2, closer to 1, so about here. Okay, so you are now responsible for doing pages 68 and 69 on your own. Whenever you're done, just put your workbook back where it goes in the classroom. If you have any questions, please let me know.